do not have to watch this video. It's totally an extra video with some of the ways that you can do model selection that we mentioned, but some students are curious to see it. So if you're one of those students who's really curious about how to do other methods, I thought I would make a real quick video. Let's load up that morphometric data set that we just played with in the last video, and I'm going to create a fit where an LM of the variable I want to predict based on all the others. That's what the dot does, and I have purposely avoided letting you see that notation, but this is an extra video that many of you may decide not to watch. It's because I need students to see what's going on, so I need you to see all those variables. So I don't do the dot because you can't see all of them, but there, that fit has all the variables in there predicted, and here I can say let's go backward, and it's going to start clear up here, and it says, okay, what would happen if I took out shoulder? And it's looking at what would happen to the variance and the sums of squares, and there's AIC, which is kind of the same idea as the adjusted R squared, and what would happen if I took none of them out, and what would happen if I took these? Well, it noticed that taking shoulder out did the best as far as reducing that AIC, which is what we want because this is a measure of variability. And so just like we did, it starts removing variables. It takes shoulder out and looks at them, and bicep seems to be doing the best at lowering that AIC next, and so it gets rid of bicep. Now, it's not just lowering the variance, it's lowering the variance relative to how many other terms are in the model. So getting rid of neck seems helpful, and down here getting rid of chest. Under that is none, but we're going to get rid of chest first, and then look, leaving none of them is what does the best, and so that's where it stops. And this is the final model right here: forearm, waist, height, calf, thigh, and head. So that's backwards regression. Forwards regression would be really hard to do by hand. Would have to go through all the models that have mass predicted by each one. Calf by itself, head, thigh, height, all of them by themselves, and look at which one gave you the best model. And then you would add that one variable in and start over to try to find out which variable would be next. So it's a lot of work, but we can ask R to do it for us. And if we go up to the top here, it looked at all these variables. Which one did the best? Well, adding in waist did the best. So then it adds in waist. And then which one does the best? Forearm. And so it adds in forearm. It adds in height. It adds in thigh and head. And then it adds in calf. And that's where it stopped. Now, it actually ended up getting the exact same model, which is not surprising. Realistically, most data sets, that happens. You go forwards or backwards, you end up getting either the same model or something really close, even though they took such very different paths to get there. There are data sets where it does matter and you can get different models both ways. It's just more rare, and it's not happening with this one. Now, we also mentioned that you can do best subsets. In order to do that, because it's a hard program, you have to go through every possible model and compare them. I need to install a different package, which is Leaps, and it's going to squawk because I've already installed it. But if you run this yourself, it might pull up a little menu asking you what location you want to pull from. I usually pick Iowa because they have some really good package lists there, but Leaps is the name of the package we want. If I say library Leaps, that actually tells R to pull in that package and use it, and I can ask it to do a plot like this, which is really cool if I can size it out and make it look big for this video. Alright, so what does this do? It says, here's all the different models that had good levels of BIC. BIC is similar to AIC. It is a lot like R squared. How can we get good values here? If you want the very best, here's their suggestion. Use forearm, waist, height, thigh, and head, which actually using this method, it doesn't have calf, although it does recognize calf can be included and get you about the same quality of model. Or you could have a model where you didn't have calf and didn't have head, and that has about the same BIC. Because these values are rounded, we don't see that these are actually slightly lower as we're going down. Here's a model that includes chest, forearm, intercept, waist, height, calf, thigh, head, and it was a pretty good model. If you go down here, if you want not so great, just the intercept and waist is better than nothing. So if you go on to take the class after methods, which would be the regression class, you'll get to play with this in more detail and How do we see these different models? How do we compare them? How do we pick one? Those are all questions that the regression class goes through in detail. And you are not required to know them for this class, but if you're interested, there are ways to get the program R to do this for you quite easily.